Hi, today we are going to discuss low-level design of an smart elevator system with multiple lifts. This elevator system is mostly used in large office buildings. And this system works slightly different than your regular lifts. There is a keypad in the lift corridor. Users go and enter their destination floor in the keypad and the lift number is assigned to them. Once the lift number is assigned to them, users go and wait in front of the lift that is assigned to them. So what we are going to do today is, we will first of all go through the problem statement and the different requirements. Then we are going to break the problem in different classes such as class lift state, and class lift request and other classes. After that, we will discuss the use of state design pattern for solving this question. A lift has three states: going up, going down, and idle. Then we will write Java code according to the classes and design patterns that we discussed. Finally, we will test our completed solution on CodeZym. You do not need to add a main method or any testing code yourself. This is all taken care of by the CodeZym testing engine. Let's start with the problem statement. This is question number 2 on CodeZym. You have to design a smart elevator management system with multiple lifts and multiple floors. The lifts are numbered 0 to lifts minus 1 and floors are numbered 0 to floors minus 1. In a lift, maximum 10 people can be there at any given time. And it takes exactly 1 tick or 1 second for a lift to move up or move down one floor. And for simplicity, let's assume that the wait time for people when a lift stops, and whether one person or multiple people are coming in or going out of lift, that wait time is 0 seconds. That is, we ignore that time. Now let's discuss the different methods that we need to implement. The main functionality of an elevator system is that users can request a lift to go to their destination floor. On each floor, user will enter destination floor on a keypad. Start floor is the floor user is currently at. Our code should return either lift index from 0 to lifts minus 1 or minus 1 in case none of the lifts can be assigned to user. The lift assigned to request must be both most optimal and eligible. Most optimal simply means that lift takes minimum time to reach start floor, that is the floor where user is at, as compared to other lifts. If there are multiple such lifts, then return lift at the smallest index from 0 to lifts minus 1. Now let's discuss the eligible part. Below are some reasons as to when a lift cannot be assigned to a user. The first one is lift has already passed the user. For example, let's take this request. User is requesting to go from floor 2 to floor 8. And lift is also going up and it is at floor 4 now. But this means that lift has already passed floor 2 and so it cannot be assigned to this user. Let's take the second example. The user wants to go down from floor 18 down to floor 0 and the lift is also going down and it is at floor 16 right now. But it means that lift has already passed floor 18 while going down. So both these requests the corresponding lifts cannot be assigned to them and the lifts are not eligible in this case. Coming to the second eligibility criteria of request lift method, it states there are already requests in opposite direction and assigning lift to a new request will increase wait time for people waiting in the opposite direction. Let's take an example. The lift is going up and it is at floor 8 and the request it is serving are 0 to 9, that is going up, 7 to 12 again going up, 6 to 10 again going up, 10 to 6 this is going down, 12 to 8 again going down and 18 to 9 that is going down. Below are some of the requests. The request 20 to 0. This request is not eligible because it will increase wait time for 10, 6, 12, 8 and 18, 9. Earlier the lift had to go up till floor 18 but now it had to go up till floor 20. So the wait time for these three requests have increased and the request is not eligible. The second request 922, again this is also not eligible. It will also increase wait time for the 3 down request because earlier it was going up till floor 18. Now we have to go up till floor 22 to you can say for this user to reach their destination. And the final request lift 16.0, this one is eligible because it lies in the way. So it doesn't have to go higher and so wait time for no user has increased. Next is method tick. This method is called every second so that you can appropriately update lift states. For example, lift is going up and it is at floor 4. So after the tick call, it should reach floor 5 while going up. Another, a lift is suppose going down and it is at floor 4. So after the tick method call, it should reach floor 3 in the down direction. Again, let's suppose a lift is idle and it is at floor 4. So after the tick method call, its state should remain 4i because the lift will not move. We should use this method to keep track of time or time passage of each second rather than using java.util.date.time. Next method that we need to implement is getLiftStates. This method returns a string list of size lifts where each item represents floor and direction of the lift. It will be an array of strings in this format. For example, the first element is 4u, 12d and 0i. So there are 3 lifts in our system. Lift 0 is at floor 4 and it is going up. Thus lift 1 it is at floor 12 and it is going down. And lift 2 is at floor 0 and it is idle. The next method that we need to implement is getNumber of people on lift. This method returns how many people are on the given lift right now. The lift ID will be between 0 to lifts minus 1. And not to say maximum 10 people can be there on a lift at any given time. The second method that we need to implement is getLiftsStopping on floor. So basically it is used to show to the user which lifts are going to stop on their floor and in which direction. The direction U is for up, D is for down and I is for idle. This question will be tested in a single-threaded environment, and in the beginning all the lifts will be idle on 0th floor, and there can be at max 100 lifts and at max 200 floors. Let us see a few method calls for understanding the problem better. The system is initialized with 6 floors and 2 lifts. The first request call comes to go from floor 0 till floor 3. This request is assigned to lift 0. Both lifts will take same time 0 seconds, but since we have to choose the lift at lower index, so lift 0 is chosen. Then the tick method is called. Lift 0 already has a request, so it has reached floor 1 in the up direction. Lift 1 remains idle. Another request lift comes to go from floor 0 till floor 2. This time this request is assigned to lift 1, who takes time 0 seconds. Lift 0 is not eligible for this request because it is already reached floor 1 in the up direction, so it has already passed this floor 0 and this request. Next tick method is called again. So lift 0 reaches floor 2 and lift 1 reaches floor 1, both in up direction. After that, request lift is called to go from floor 0 till floor 5. Now lift 0 is already at floor 2 in up direction, so it is not reachable for this request. And lift 1 is also on floor 1 going up only. So this lift is also not reachable for this direction. Since no eligible lifts are found for this request, so we return -1. Another request comes to go from floor 1 till floor 0. So this is a request in the down direction. Here lift 1 is chosen. Now lift 1 is already at floor 1, but the direction is different. It is going up. So what lift 1 will have to do is, first of all, it will go up till the maximum floor, that is floor 2. To complete this request at floor 2, the first person will come out of the lift, then the direction will change, and then lift 1 will come back to the floor 1 so that the second person can enter. So total time taken will be 2 minus 1, that is 1 second here, and 2 minus 1, 1 second here. Total 2 seconds will be taken. Okay, let us see the last method call. Just to remind you, the previous state, lift 0 was at floor 2, it was going up and it was serving only 1 request. Lift 1 was at floor 1, it was going up and it was serving 2 requests. So tick method is called. Now lift 0 has reached floor 3. At floor 3, the only request it was serving, that person got out. So now there are no more requests and lift 0 is at floor 3 and is in idle state now. For lift 1, it was at floor 1, so now it reaches floor 2. At floor 2, the first request, that person got out, so now it has only one request, 1 0. And since that request is in down direction, so the direction of lift 1 now changes to going down. So this is how the state change works. Here are all the methods of class solution. We don't have to write any public static void main method or write any testing code. CodeZym's testing engine will directly call these methods using class solution object and test it all. Let's break the problem in different classes. Class lift and class lift request are obvious given the methods we saw, and we will be using state design pattern here. And there are three states of a lift. It's going up, going down, and standing idle. Starting with the simplest, class lift request has a start floor and a destination floor. A start floor is the floor on which user is currently on. It also returns the direction of the request since it has both the start floor and destination floor parameter. So it can tell whether user wants to go up or come down. Next is class lift state. We'll go through implementation of concrete classes later. Floor and direction are the two parameters which form lift state. And updating lift state means updating these two parameters. So these two methods, update floor and update direction, will be called every time after the tick method is called. Method get time to reach floor will be used for assigning lift in the request lift method. It will either return -1 for not eligible lifts and time taken to reach for eligible ones. We can pick the lift which takes least time using this method. We could have put all this code in a single class rather than using three classes, but that would have resulted in complicated code with a lot of if-else statements. And state pattern is the cleaner way to do this. You will get bonus points in interview if you use it in your solution for this question. Before we discuss class solution, these are the important methods in lift class. There are other methods and we will go through them when we are discussing code in class solution. Current floor is the floor lift is currently at. State is the current state of lift, which will be either of moving up state, moving down state, or idle state. Add request is for adding request, that is user's request. Update lift state will be called after the tick method every time, and has stop will be called to check if lift stops on a given floor. Let's start from the top and go through methods in class solution. Floors are numbered 0 to floors -1. Lifts are numbered 0 to lift count -1. Helper is used for logging and debugging. Use this instead of system.out.println, else your logs won't be visible. We have an array of lifts which will be representing all the lifts in the building. Init method initializes all the variables and the lift array. And we will go through the methods in class lift as we move further. First method is request lift. Start floor is the floor where user is currently at, and this method is called when user presses destination floor button on their floors button panel. Basically, what we do is we go through all the lifts and calculate the time taken to reach start floor and destination floor. The logic for calculating time will reside with the state classes which we saw earlier. Just now we saw this method get time to reach floor has the code for time calculation, and we will see the actual code for this method for all the three state classes implementing the lift state class in a few minutes. After calculating the times, we also check if the lift has space for an extra person between start and destination floor. If lift has extra space and both time values are also valid and the time to reach start floor is less than existing value, then the lift is selected, and finally after going through all the lifts, the request is added to the given lift. The first thing that request lift does is it calls the has space method in the lift class. If you remember, each lift can carry maximum 10 people at any time. So we need to check if the lift will have extra space for one more user at all floors between start floor and destination floor. So based on the request direction, we go from start floor to destination floor and count people on each floor. If there are going to be 10 or more people in the lift and any floor, then we return false. We will look at the code for counting people or count people in a few minutes. The second thing that request lift method does is it adds the request to the lift that is selected finally. This add request method is called. When add request is called on a lift, then first of all, a new lift request is added in the array list requests, And if this is the first request, then lift's move direction is calculated based on whether user's start floor is above or below lift's current floor. After that, set state is called. Set state updates the current state of lift based on the movement direction. So this dot state will be moving up state in case direction is up, moving down state in case direction is down, or it will be idle. Next method in class solution is tick. This method is called every second so that lift states can be appropriately updated. We use this time rather than using java.util.date.time. This method calls update lift state on each lift in the building. When update lift state is called on a lift, then it first of all updates the current floor, that is do current floor +1 if lift is going up or current floor -1 if lift is going down. Then it calls update request method, which actually simulates people moving out of lift. And finally, it calls the state object to update the direction method if required. For example, if lift was going up and now all up requests are finished and only down requests are there, the state of lift will be changed to moving down. The method update requests in lift class actually mimics people moving out. So it basically removes requests from all users who have reached their destination floor. So what it does is it goes through all the requests it is serving, and if the lift has reached or passed the request destination floor, either going up or going down, then it doesn't insert the request in the temporary list, which it calls as new requests. And finally, after going through all the requests, the request variable becomes the new request. That is, new request is assigned to the request variable, and it doesn't hold all the old requests. Next method in class solution is get lift states. It returns a string array, and now a lift state is made up of two things. The first is the floor where the lift is, and the second is the move direction of the lift. So element 0 is lift state is 4u, so it is basically at floor 4, and lift 0 is moving up. And since the number of elements in this string array is 3, so the number of lifts in the building is also 3. To get the lift states, our code in class solution goes through all the lifts and it simply appends their current floors and the move direction and puts them in the lift states array and returns that array. And basically current floor and direction is tracked by the class lift. Current floor lift itself tracks, and the direction is fetched from the state the lift is in. Let's revisit the earlier example. Lift 0 is 4u, that means it is at floor 4 and it is going up. Similarly, lift 1 is 12d, so it is at 12th floor and it is going down. And lift 2 is 0i, that means it is at ground floor, floor 0, and it is idle there. Next method in class solution is get number of people on lift. And as the name suggests, it counts the number of people on a given lift. Right now, the actual calculation is done in the lift class in the count people method, which takes the floor and the movement direction. Coming to the method count people, since each lift keeps track of the current and upcoming request, so using this method, we can calculate the number of people in this lift on a given floor in the given direction. What we do is we go through all the requests the lift has, and we only consider the requests which are in our move direction that we need. And then what we do is we count the request where floor is either equal to start floor or it lies between request start floor and destination floor. Let us assume that a lift has 3 requests, go from floor 0 to floor 4. The next one is to go from floor 2 to floor 6, and the last one to go from floor 3 to floor 4. Count people method on floor 0 will return 1 because user from floor 0, this request 0 to 4 will be the only one there. Count people on floor 1, lift going up will also return 1 only, because in this lift till now there only one person has entered. Another user is going to enter on floor 2, so when we do count people 2 and direction is going up, then it should return 2. On floor 3, another person will enter the lift, so count people on floor 3, lift going up, will also return 3. On floor 4, user 0 and user 2, who made the first and the third request respectively, will go out, and so only the second user remains. So count people on lift floor number 4, and lift going up will return 1. Final method is get lifts stopping on floor. This method is used to show users which lifts will be stopping on their floor along with the direction, that is whether moving up or going down. So what we do is we simply go through all the lifts, and if lift has a stop on the given floor, then its lift ID will be added to the lift IDs list, and finally lift IDs will be returned. The actual has stop method is with the lift class. Coming to the logic of has stop method in class lift, as we know that a lift only stops at either start floor or destination floor of a request. So we simply loop through all the requests that the lift is serving in the given move direction, and then we return true if any request start or destination floor is same as floor. Finally, let's discuss the implementation of all 3 lift states, that is moving up, moving down, and idle state. Starting with the class moving up state, this method get max up floor is used in rest of 3 methods. It determines the maximum floor that the lift will go up to based on the current requests before the lift becomes idle or starts to come down. So the get max up floor is the point at which lift changes direction or basically changes state. So what we do is we go through all the requests and simply choose the maximum start or destination floor and return it. The method update floor checks if the lift has reached its highest point, that is get max up floor. If it has not reached, it means that lift will still go up, so it sets current floor to current floor plus 1. Again, the method update direction, it also checks whether the lift has reached the maximum point or not, or the topmost floor that it needs to reach or not. If it has reached there, then it updates the direction to D, that now the lift will go down. The method get direction, it has to return U only because this is the implementation of moving up state. The last method in moving up state is get time to reach floor. This method will be reused by request lift method in class solution to pick a eligible and most optimal lift. This method returns -1 if the lift is not eligible for a request, else it returns the time taken by lift to reach user's floor. Coming to the logic of get time to reach floor, if user's floor is more than max up floor, that is the highest point lift intends to go to, and there are requests in opposite direction, then this request is not eligible because it will increase wait time for people in opposite direction. If the request direction is also up and lift is on the same floor, then the time taken will be 0. And if lift is already above this floor, then this request is not eligible. So again we will return -1 because lift has already passed this floor. Else time taken will be the distance between floor and lift's current floor. And there is a final case where the request is in opposite direction and is less than max up floor. That is less than the maximum point the lift will go up to. So the lift will have to actually go up and then come down to the floor. So the first calculation will be max up floor minus current floor, that is going up, and then from max up floor it will come down to floor. So max up floor minus floor, and that will be the total time that will be returned. Next state class is moving down state, and its code is almost similar. Here the min down floor is the minimum floor at which lift needs to go to serve its current request and before changing its direction or state. So what update floor does is it checks whether the lift has reached its minimum point, that is get min down floor. If it has not reached this, then it means that lift will still go down. So it does lift dot get current floor -1. Again, the update direction also checks whether the lift has reached its minimum point or not. If it has reached, then it changes the direction to move going up, that is U. Get direction, since this is a implementation of moving down state, so it will always return D. Coming to the logic of get time to reach floor inside the moving down state, it first checks whether if the lift has to go below its minimum point, that is min down floor, to reach the given floor, and it has request in opposite direction, then it will return -1 because this request is not eligible for this lift, as the request time or the wait time for people in opposite direction will increase. If the request direction is also down and the lift is already on the given floor, then it should return 0 because lift is already there in the given direction. If the floor is greater than current floor, that is lift has already gone below the given floor, then it will return -1 because lift has already passed this floor. Else it will return the distance between lift's current floor and the floor. And finally, there is a case where the floor that we are looking for is above min down floor and the request is in opposite direction. In that case, what we have to do is lift has to go from its current floor down to the minimum down floor, and from there it has to go up to the floor. So there are two sums, current floor minus min down floor while going down, and floor minus min down floor while going again up to floor. So this will be the final answer. Class idle state is simple. The direction will return I and get time to reach floor will return the distance between floor and lift's current floor. And there will be no non-eligible, not eligible cases here. All the requests will be eligible for a ideal lift. Now that our solution is complete, it's time to test it. Let's select all the code and paste it in CodeZym's code editor for testing. This is question number 2 on CodeZym, design an elevator management system with multiple lifts. Now that we have completed our solution, it's time to test it. So let's hit the run button. And I actually wanted to show you something. Yes, the test, this compilation error has occurred because there is a duplicate interface definition for this smart elevator group interface. So why did that happen? It happened because the code which I copied in the beginning, I had uncommented this helper code. So I need to comment it back. Only then our code will compile. So when you are coding, you should also remember this thing. Let's run it again, and this time it should pass all sample cases. So it passed and it took 2.5 seconds. I also wanted to show you how an error looks like so that you can debug easily. So this is the request lift method from the class solution. So what we do is let's add a +1 to it. So it will give error and we can see how can we debug and how it looks like. So it shows that test failed, even the first test failed, your code returned lift 1 and actual return value should have been lift 0. Then it also gives what is the calculation for lift 0 and what is the status of lift 1, so that it will help you debug your error in logic or any error that you have made. So let's make it again and let's now submit and check if it runs and passes all the test cases. As the test cases keep passing, we will see this number getting changed time again and again. Now that all the test cases are passed, so we are confident that our code was indeed correct. Seeing your code run and pass all the test cases gives you the confidence that if you get this or similar question in an interview, then you will be able to do well there also. I will put all this code in a blog and put link to the blog in description. Keep trying other questions from the CodeZym website. And I wish you the best of luck in your interview preparation, and I hope that you get the job and salary that you are looking for. Thank you.